Hello and welcome to Outside In. My name is Steven. Today we are going to be looking at the AirKnight air quality monitor. We're going to be looking at replacing the battery that's inside of it. Someone left a comment that when I do this I should use a diode, a Schottky diode. But I'm almost positive that we're not going to need to use a diode in here. And the reason for that is that some of these devices that have polymer batteries in them only allow the voltage to go so high, and then in the board itself it cuts the voltage off. We're going to be testing this live again, but in my testing this is just under 4.2 volts, which would be perfect for 18650. I also found an issue using diodes. When you use a diode, the current flows one way and it will not come back. Okay, so with this device and with devices like this, more than likely what charges the battery also needs that voltage to come back to the same location to power the unit if it's running on a battery. Now some devices aren't built that way, but this one is. I've already looked at that. So a diode would not work in here simply because the voltage would go to the battery, but then there would be nothing coming back from the battery to power this. But then I thought of something else. Well, why not use two diodes? One going one direction in voltage and then put them together but backwards. So that way the voltage goes forwards and it will come backwards into the device. Well, I discovered an issue with that as well. When you use a diode to drop the forward voltage so it will be safe to charge an 18650, if you put two of them together, one going forwards, one coming backwards, the voltage coming from the battery will also be reduced. So that could be an issue. But if we have to, we're going to test that. But I don't think we're going to need to use diodes because of something that I discovered when I was testing this. And we're going to, like I said, we're going to look at this again and we're going to test it again once I get this apart. But first things first, let's take this apart and so you can get out your AirKnight and follow along. Now, I'm leaving this plugged in only because I have let this run for 2 days after the battery charged. After 2 days of running, I wanted to check again what the voltage going to the battery is, if it's still below 4.2 or not. But anyway, let's take this apart. Okay, now the first thing we'll do is use a spludger. Top of this case has to come off. Now I've had this off a few times. Now the first time you do this, it's a little difficult, so just be careful that you don't break anything. Then remove that, set it aside, and now there are 4 screws. 1, 2, 3, and 4. We have got to remove those. And then set those aside. Don't lose them. Now my air quality is showing bad right now only because I've been messing around in here and soldering and stuff, so fumes and things. Plus just plain moving around a lot like this gets dust particles stirred up, which will cause a monitor to go a little nutty. Alright, now after you got these 4 screws out, then what you'll do is take your pry spludger and then start getting it in here and get out the one side, pop out the one side, and then pop out the other side. Okay, and then move that piece aside. Now this screen here, just be careful, pull that up and bend it over. And this is the polymer battery that is inside of this. Now just first thing we're going to do is I want to test the voltage here, because the voltage is coming from here to the battery, and then the battery is also sending voltage back to this so it can power the unit. If you want, you can desolder the battery and remove it and leave the battery out. as long as it's plugged in, it will run, because this will run with a battery or without it. But let's test the voltage here where it's going to the battery. 4.21 volts. Now, some would say, all right, yeah, but you're over 4.2. You're right. But I think you should be okay as long as you're within 4.23. I mean, you don't want to go up to 4.3 volts, obviously. And you really don't want to go over 4.2 on an 18650. But I've done lots and lots of research, and most every bit of research that I've done, most people are saying just replace the battery with an 18650 and you'll be fine. Here's the problem with that, though, with that logic. Some devices allow the lithium polymer batteries to go up to 4.35, I think it is, volts. That is a big no-no for 18650s. You definitely do not want to go that high with an 18650. You can either take the battery out and just leave a battery out and just use it with a power bank to power this, which would be great. Or you could use a wall wart 5-volt supply to power it, or you could add your Schottky diodes. But we're going to have to add 2 diodes, one facing each direction, so the voltage will go, the current will go from here to the battery, and then another diode facing the other direction to come back, so the power can come back from the battery to power the unit. I've been running this for 2 days. Left it plugged in for 2 days. 4.21, which I would feel comfortable with that. So let's go ahead and unhook the battery. Now just make sure when you do desolder this, you definitely do not want to short this battery out. So just to be safe, once you desolder the one side, you might want to clip this wire, so there's no hanging wire that could accidentally short out. You don't want to short the battery out. Definitely do not want to short a lithium polymer battery. Okay, then let's cut this one. Alright, so now let's test this voltage again in the same location to the battery. Okay, 4.2. So the output voltage to the battery is 4.2 volts. So I don't think we're going to need a diode in here at all. But you can if you want. I'm not saying not to do it. I'm not going to do it. 4.21 volts is acceptable. Okay, here's the thing. If you use a Schottky diode, just remember that there's going to be a voltage drop. And let's show you what that is. Let me zoom in here. So you can see this. This little ring means that the voltage is going that way. If you turn it this way, the voltage is coming this way. But it won't go back. So if you have voltage going to the battery, you will also need voltage coming back from the battery. So see the ring here on this one to go out to the battery, the ring's down here for it to come back. But here's the problem with doing that, and we're going to show you that right now. Alright, now the battery would be up here, so we'll put the probe here and we will test the voltage. Well, let's zoom back out so you can see the alright, now that's taking that down to 3.9 volts. 3.9 volts. So that also means that from the battery, volts 3.8 volts coming back from the battery. But now this battery is not completely fully charged. 4.1 volts the battery is. But at 3.9 volts, which is what, if you put a diode in here, it's going to charge the battery to 3.9 volts. What will be coming back is probably going to be around 3.6 volts. So let's test it with a power supply. If you use a diode, one in 4007, I tried about 6 or 7 different diodes and they all registered exactly the same voltage, drop voltage. Okay, it's going to put 3.95 volts into the battery. So let's set 3.95. I'll set my power supply to 3.95 volts, and then we're going to see what the output from the battery would be. 3.6. So that means 3.6 volts would be all that would be going to the AirKnight. And I'm thinking that would be enough to run it. But let's look again. When the 18650 gets down to 3.5 volts, then 3.1 is what will be coming into the AirKnight. Will it even run on 3.1 volts? Let's see. Let's unplug it. How low this will run. Okay, this is set at, I have the power supply set to 3.5 volts. Will it power this device? Okay, it's running, but it's saying that the battery is down to half. Let's take this down to, let's just take it down to 3 volts. See if it will power it. Doesn't look like it's enough to keep it going. No, it's not enough. Alright, 3.1 volts. No, 3.2 volts. 3.3. Okay, 3.3 volts is as low as I can get this to go. When I get this down to 3.3 volts into this for the battery, it's showing 1 bar of power. So actually, 2 diodes together facing in the opposite direction of each other will allow enough voltage to go to and back from the battery to power the unit. So if you would rather use diodes, which I am not going to, because like I said, it's 4.2 volts, but you could use 2 diodes like this to solder them together on the positive side, so that way juice can go to the battery and come back from the battery to power the unit. And the voltage drop is probably going to be around 3.6 volts going into this, but this will go down to 3.3 volts and still run it. But that's up to you if you want to do that. But if you only use 1 diode, that's not going to work at all. It'll allow juice to go to the battery, but then nothing will be coming back from the battery to power the unit, so it'd be kind of pointless to have a battery. So now let's look into, let's unplug this to make it easier to work on. Unplug this. Unplug that. Alright, now this is the battery right here and it's glued in. Just be careful trying to get this out. I really do not recommend using a metal spludger, because you definitely do not want to puncture this LiPo battery. So what you could do, if I can find it, what did I do with it? Could you use something that's plastic? That glue is sticking. Yeah, but just be careful. Oh, see, look at that, I broke that off. Wow, I broke that. I guess that was kind of a junky made thing. Alright. Yeah, just be careful with polymer batteries. Just be careful. And then you can spend some time getting that glue out of there if you want to. And there, we got it. Alright, just make sure you don't use one of these metal spludgers when you're trying to get that battery out, because you definitely do not want to puncture the battery while you're trying to remove it. Okay, so now we just need to put our battery together. And I'm using 1.5 nickel strip, but this is pure nickel here. But you don't need to use pure nickel. That's totally up to you what you want to do. But we need to cut this to the right length. Now what you'll want to do though, before you spot weld, you want to cut this just a little bit long. You want to cut 2 of them the same length. Now you'll want these a little bit long, and this is why. You need to be able to hook some wire to hook this battery up to the board, to the circuit board. And you don't want to be soldering on the battery after you've spot welded it. So what I would recommend is just getting a little piece of wire, and I'm just going to cut it off longer than what I need so I can adjust that later. Put a positive on this one and a negative on that one, so that way we're sure to spot weld them on the right side of the battery. And first we're going to weld or solder. And that's tin the wire. Let's get this. Let's get these nickel strips pre-soldered. Okay. All right, now this is going to go to the positive side of the battery. So let's go ahead and get that soldered in. Solder the negative side. Get the spot welder turned on. Spot weld the positive side. Then let's spot weld the negative side. Then that way we can bend the tabs over, and now we have our battery made. And then let's move our spot welder out of here. Let's get our wires ready to be soldered back onto the board. Let's tin the wire. Alright, now let's test the voltage here. 4.1 volts. Okay, now these batteries, how is that going to fit in there? Oh no. Well, Alright, you're seeing it exactly as I am. I really was hoping 2 was going to fit in here. 2 does fit, but it won't go down. The way this case is made, it won't go down. So what we're going to have to do is put 1 battery. That's a shame. Wow. If this case was just an 1/8 inch taller, wow, it would work. But we're going to have to cut the battery off and just use one battery. And you could hot glue that in there. Alright, so now this says, zoom in so you can see that on this board. B plus, B minus. That means battery plus, battery minus or negative. So make sure you solder these back in the correct way. And we pre-tinned our wires already. Let's just go ahead and put some fresh solder on these joints here. Okay, now our battery is back in. Get all this stuff plugged back in again. Okay, and it's working beautifully. Alright, so let's go ahead and plug this in, the power back into this. Alright, let's check the voltage going to the battery again. .19, so it's less than 4.2 volts, which is what this was showing before with the polymer battery when I first tested this. But after setting for 2 days, being plugged in, it had reached 4.21, 4.22 volts, which really isn't that bad at all. I'm going to run it like that. Now, anyone who wants to use the diodes, then by all means, please use diodes. But you're going to have to use 2 diodes, one going to the battery, and then you're going to have the second one. But let me show you once more if I can find them. Let me zoom in here and show you. Okay. The ring, this would be going to the board. This would be going towards the battery. So the power can run from the board to the battery to charge it. But you're going to need another one of these going in the opposite direction and put them together. So you can have juice going to and from the battery. So this can be powered. The only drawback to that is that the voltage drop going to the battery, there's also going to be a voltage drop going from the battery back to the unit itself, which I don't know if it would kind of sort of be defeating the purpose of having batteries at all. That's up to you to do whatever you want to do. There's probably going to be some people saying that it's not a good idea just to stick an 18650 in there without a voltage drop. But like I said, let's look at this again. Less than 4.2 volts. I'm going to leave this plugged in for a little while and see. Even if it does go over 4.2, it's only going to be just a little teeny tiny bit. 4.22 was the highest I've seen. 4.22 without a battery. After running for 2 days with this plugged in with a polymer battery, it was at 4.22 volts, which still to me is fine. But if you would rather just put, you're going to have to use 2 Schottky diodes so the voltage can run in both directions. Did a lot of research. I have not found a single diode that goes in both directions. Diodes go one direction and won't come back. And without the juice coming back from the battery to the device, it's pointless to have a battery. So you would need 2 diodes, one going this way and the other one going back the other way. But also know that your voltage drop is also going to be both ways. Okay, so you can glue this in if you feel more comfortable. You can glue this 18650 in here now, but you really don't need to. We can just go ahead and put it in there. Okay, and there it is. The polymer battery taken out and an 18650 in there. I really thought 2 was going to fit in there, but even if you could have forced it in there, it wouldn't have been good, probably because it was pushing this side out and it may have ended up breaking the glass display trying to force it down on there, which is unfortunate. If the angle of this would have come up square, it'd have fit perfect. Or if this whole thing was just a 1/4 inch taller, it would work perfect. But at least one 18650 is a lot safer than those polymer batteries. Yeah, I really do think also that the 4.22 volts that is going out there, I don't think it's such a big deal. For me personally, I don't see a problem with that even after 2 days. And right now it was even putting out less than 4.2 volts. And yesterday, 2 days ago, when I first started this test with the voltage, the battery was completely charged, the polymer battery that was in it, and it was still only showing 4.19 volts going to the battery. And after 3 hours, it was still the same. It was less than 4.2 volts. After 5 hours, it was still less than 4.2 volts. But after 2 days of sitting here, it's showing 4.22, which to me is acceptable. Definitely 100% acceptable. But if you feel more comfortable, then by all means, use the Schottky diodes on the red wire. But make sure you use 2 diodes, one going one direction and the other one together going back, so voltage can run forwards and back from the battery to the battery and back from it. It's up to you what to do. I was just showing you how to do the replacement. Then your polymer battery, put it on a slow discharge and discharge it to a safe voltage. Take it down and properly dispose of it, and you'll be good to go. I just will feel a lot safer with this not in the house, for me anyway. And my other polymer batteries that I use for the spot welder, I have fireproof safes to keep those in. And that makes me feel a lot more comfortable having a fireproof safe to keep my batteries in. Now, if you want to keep this around for the use or something else, you can always throw it in your safe as well in case it decided to go bluey. I just don't like polymer batteries unless I absolutely have no choice. And with a cell phone, you have no choice. And with quadcopters or drones. But there you go. That is replacing the polymer battery in this AirKnight with an 1860 lithium ion to make it a lot safer. And hopefully you got something out of that. And stay tuned for, I have an interesting video coming up about 2 of the Diodes air quality monitors. So stay tuned for that. I'm still doing some finishing touches on the case that I'm building for the video, so hopefully that will get finished this week and I can get those videos up and out. So take care of yourself, take care of each other, find someone that needs to laugh, make it happen, and I will see you in the next one.